Hi everyone, Victor here. How's everybody doing? So the other day I was watching a video about metaballs, and in computer graphics, metaballs are organic looking n-dimensional surfaces characterized by their ability to melt together when in close proximity to create single continuous objects. So yeah, we have balls or spheres, and when they get together, when they get close to each other, they melt, like the article just told us. Yeah, it's pretty simple code, to be honest. I just end up creating a class called Metaball that has its x and y position, this angle, this velocity, this size. Over here we calculate the direction based on the angle of the metaball, and here we just bounce on the screen. I end up copying from the internet, to be honest. I lifted this code from Stack Overflow, I guess. A smooth step function, which is basically a mapping function, to be honest. So anyways, here we initialize the code, we get the canvas, the pretty basic stuff, and then we create 5 metaballs with random attributes like x position, y position, angle, velocity, right, and size. And then I create a new image data. So instead of drawing balls, I'm manipulating the unsigned integer 8-bit clamped array. Yeah, this over here, just a array that goes from 0 to 55. Yeah, 55. Sorry. Yeah, and then we update each metaball. Just add to the position the direction. It's just pretty basic physics, and we iterate over the image, and we just took the distance. Over here we are taking the distance to each metaball, and then we use the smooth step function to kinda clamp the values between 0 and 2. I don't know why I can't say this. 255. Yeah, 255. Okay, and then you just put the image. So this is what we get, right? By the way, this is live. You can go to my website, Metaballs, and you see this. So if you guys know anything about shaders, this code that I wrote is mimicking a shader, a GLSL shader, because I'm gonna show you the shader version of this. Yeah, I did wrote a shader version of this, but we're going pixel to pixel and measuring the distance of that pixel to the metaball. And over here we're accumulating the distance and just pasting the distance as the pixel value, right? Yeah, and my goal with this project over here was to see how fast I can do that, because it's usually pretty expensive to process this kind of image without a GPU. So this code is running on the CPU, right? Because it's in JavaScript, in using Canvas, no WebGL on this code over here, just regular 2D Canvas. Yeah, and it was kind of fun to do this. It was a nice code session. So after I was done with this, I ended up creating a GLSL version of this. So this is a shader. This one is kind of fast. It's faster not because it's faster. It's because I'm animating things faster over here. We can, like, this one is kind of slower and this one is faster, but it's because of the speed. Like, I can change the speed over here. I time let me, I think I can just, no, I need to compile this. No, yeah, iTime. Let me compile again. See, now it's slow. We can slow it even further. Let me. Yeah, now it's as slower as this one over here. So the speed has nothing to do with this. But yeah, continue my train of thought that is lost a long time ago. If you know anything about GLSL or shaders, I'm not the most proficient with shaders, but a shader code goes pixel to pixel and running a program to determine it, to figuring out which color should that pixel be colored, right? So that's exactly what I'm doing. So I create 5 balls or spheres, and then I measure the distance to each one of those balls and accumulate it like we saw on the other code, like we're accumulating it here. Dist over here, just call it D, because I don't know, in shaders people used to really dry up the code, and if something is called distance, they usually call it D. Okay, so where this 1 over the length of the UV minus the balls, this is the distance between each pixel and the balls, like I did over here. This mat square, dx times dx is just dx square, right? So dx squared plus dy delta y squared, and you take the square root of that, is just this length function over here. That is the Euclidean distance. Where that come from? From this equation over here. Over here they are doing three dimensions, x, y, and z, and I'm doing in just 2 dimensions, and just x and y. I don't know. I don't have that much to say about this code. I just had a lot of fun doing it, writing. This is the first shader that I wrote by myself, to be honest. I did some other experiment, but it's very simple. So this one is kind of nice, and also this one is kind of nice because this one, it's kind of fast and it's running on the CPU, as I told you guys. This one is running on the GPU. So yeah, 2 ways of programming the same thing. Yeah, hope you guys like it. You can look me up on Shader Toy by Victor Q Ribeiro. It's my name, Victor Q Ribeiro. Q is my middle name. And you can go to my website, Victor Ribeiro without the Q.com Metaballs, to watch this. I'm gonna leave some links in the description. I don't have a GitHub repository for this, but you guys can always be on source page and inspecting the code, right? Yeah, this video is long enough. Hope you guys like it. Talk to you guys soon. Bye.